Welcome to my demo video to accompany my presentation on practical password cracking, hardwares, tools, methods, and AI. My name is Sean Smith, and today I'll be walking you through a demo of the tool I created. First, a little about me. I'm currently a smart factory industrial Internet of Things technologist, also a cyber team lead, and now adjunct of cybersecurity. I have a wife and 2 young kids. I was educated in college, but didn't learn much about information security there. That mostly came from the streets of Google and ChatGPT. My hobbies include anything technology. I love 3D printing, building stuff, and pretending to code. If you'd like to learn about those projects, hit me up on my website. That'll take you right to my social media profiles or my GitHub, where you can access any of my projects, code, as well as the code that I'm about to show you for this demo. To set the stage for the demo, the experiment was to identify a method to crack hard passwords. And what do I mean by a hard password? Passwords that have extremely long length, complexity, basically current set of passwords that are required by most organizations. With the advent of AI and large language models, this is now possible. The first step was to identify a test hash dataset, which was from Have I Been Pwned. Have I Been Pwned is maintained by Troy Hunt, and he provides a downloader tool which quickly allows you to download the full set of NTLM hashes, which is beautifully organized, formatted in NTLM, and easy and quick to download. The second step is selecting and gathering the tools, which of course is Hashcat, as well as cracking rigs and GPUs. The third step is to get rid of all those easy passwords out of that 31 gigabytes by using the traditional techniques. Those include brute force, word lists, masks, and rules. Now I'm not going to be focusing on this section during the demo, but if you'd like to learn more about this, I encourage you to go to my website and read the full presentation. I will be focusing on step 4, which is the large language model to create a custom word list from which I tested the remaining hard passwords against. Based on the findings of those, I was able to analyze the results and present the findings. I'm not going to go through the findings during the demo, but if you'd like to know the results, please go to my website again and take a look at the presentation. Now, I would be remiss if I didn't start by thanking a few folks. The first being my friends from across the pond, Javier, Fernando, and Breland. These individuals performed some exquisite research and compiled their findings into a white paper. What they did is the foundation of my research. They created a GPT model that was trained based on breached data, and they published 2 models. The first being one that generates passwords of at most 10 characters, the second being 16 characters. The first model is public, and anyone can download it and use it. The second model requires their additional approval, and you'll need to get a Hugging Face account to access. Along with this, they published some boilerplate code to get you started. I took this code, as well as their models, to conduct my research and published all of my code on my website. If you'd like to learn more, please read their paper. Here's the citation. Again, thank you guys. This was extremely helpful. Back to the experiment. We first need to install quite a few dependencies to get us started. I'll walk you through those, but I'm not going to demo that. I am going to demo running the tool though. However, I did give you quite a good head start. I included YouTube videos that really helped me accomplish these steps. First, use Windows 10 or 11 for the best experience. I know, if you like Linux, I'm sorry. I found that I kept getting blue screens of death or kernel panics whenever I would try to get the drivers and everything installed for Linux. It really just ran much smoother in Windows. Sorry, everyone. Next, install the latest version of Python, then install the Python package manager. Next, you have 2 options. If you have a CUDA-supported NVIDIA GPU, you can proceed down this path and install a CUDA Toolkit as well as PyTorch GPU Edition. If you do not have a CUDA GPU, that's fine. You can install PyTorch with CPU support only. Next, highly encouraged, is to create a virtual environment. This will help you isolate all of these dependencies so that you're not breaking anything as you continue to update your environment. Next, in your virtual environment, make sure to add the additional dependencies PassGPT requires. Without further ado, it's demo time. To get started, you'll want to clone the repository on my GitHub. If you did, it should look something like this. Within this repository, you'll see your virtual environment folder as well as the PassGPT generator. Those are the only 2 files you actually need to run this. So from here, open a terminal. And if you have a virtual environment, you should enter it now. With the virtual environment, I'm going to show you one more thing before we get started. This is clearing the cache in any existing models. This is why we installed the Hugging Face CLI. As you can see here, I've deleted all the model cache. If you have models, you can select them by hitting the space bar and then hit enter and then enter again to delete them all. I have deleted all of mine, so we're starting from scratch. So it should pull the models directly from the repository. Once you pull down the models once, it won't go back and update them again. So after this, you'll only need to download the models the first time. So with that, we're ready to get started. To run the model, you simply need to type python.exe PassGPT generator.py. There's no parameters accepted. If you type parameters, it's not going to do anything different. Upon first run of the tool, you'll see that it does a dependency check. If it fails that, it'll tell you what needs to be installed. Once you install it, it should proceed forward as you see here. We have some nice ASCII art, and then it gives you some instructions on how to run. Now to stop the script, type Control-C or Command-C if you're on a Mac, and this should gracefully exit. Now it presented you with a prompt. Do you want to run the 10-character model, or do you want to run the 16-character model? The 10-character model is the default. If you type anything that is not a 1 or a 2, then it'll automatically run the public model. I'm going to type 1, and I'm going to hit enter. It's now downloading the new model from Hugging Face. It auto-selected the best compute device, which in my case is the CPU because I have nothing else plugged in. It's generating 1,000 passwords at a time, and it's spreading those passwords across 17 folders numbered accordingly. You can see here a graphical depiction as it continuously runs that shows the file size of each of the text files, the number of lines that are appended, and the distribution of those lines, how many characters were generated. Now, if you're familiar with machine learning, this is a probability model. It examined previously breached passwords, and it's attempting to recreate passwords as if a human were to create them. These passwords were never before created or exposed in a breached data set, but this AI is saying, I think I can guess what a human's going to do, and I'm going to create passwords as if I'm a human. And it's doing this, so it's creating a whole novel set of new passwords. It continuously does it over and over again, forever, until you hit Control-C to gracefully exit. Upon which time, because I only let it run for a little while, you can see that it stopped on iteration 8, and then after that, it began to perform its final steps to gracefully shut down. This includes going through each word list, sorting them, and deduplicating them. And then unique lines are remaining in each file. Now the reason why it's set up this way is because these files can potentially get very large. So I have it structured in a way where it's not going to consume too much memory, and it's divided across all the files to hopefully reduce the burden. So once it goes through this deduplication process, it doesn't delete any files. If you were to run this again, it'll append it to the file once again. Once complete, it will consolidate all those files into one folder called output. Within there will also be one additional file created, which is the consolidated output, which I'll show you now. So you can see the output was created. And if we go into this file, you can see all 17 word lists as well as a consolidated file. If we were to run this model again, it would simply add on to these word lists and then output a brand new consolidated file. So if we open up the 8-character passwords, you can see what the model generated as human probable passwords. Let's say we want to run it again. This time, we want to run it on the 16-character model. So I hit selection and hit enter. And now it's prompting me with an API key. Because as I said, this is a private repository which we need to get access to. So once you email our friends from across the pond and request access and they grant it, you will then be able to access their repo. You can go in to your settings, you can go into access tokens, and you can create yourself a token. Now, I'll show my token here. I'm going to refresh the token and invalidate it as soon as this demo is over, so you won't be able to use mine. But I'm going to copy my token, and I'm going to paste it in. Now, there's no input validation on this. It requires you to enter it in exactly as you see it on the screen, and it'll begin generating passwords with the 16-character model. This will take a little longer. We're still using the CPU, so we'll give it a second to generate. You can see our first run, and clearly the distribution is now across more characters. Based on the data it was trained with, It believes the majority of users generate passwords in this length, but there are passwords being generated upwards of 16 characters. You can see it's taking a little longer. I think the previous model took about 8 seconds per iteration with the CPU. This is taking roughly 16 or 17 seconds. I'll hit Control-C. It'll go through its process of deduplicating, and we will go back into the output file, and we can see here that there are some 16-character passwords generated in that short period of time. And if we go into our consolidated view of a word list, you can see it's ordered just as the way it was outputted. Now you're saying to yourself, 17 seconds for 1,000 lines, and then we're deduplicating. It must take forever for you to run this model, which is why this script will automatically select the best available device if you have it configured. So what I'm going to do now is I'm going to plug in my external GPU into my USB-C port. As you can see, my external GPU, an RTX 4090, has been connected. And now I'm going to run it again. I'll select the public model first. You can see here it selected the GPU and is considerably faster. It has went from 8 seconds down to roughly 0.1, 0.09 seconds. I hit Control-C to gracefully exit, and let's see what iteration it ended on just in that brief period of time. Iteration 97. Let's run it again. You can see here it's selecting CUDA, so that's how you know that it's using your GPU rather than CPU. I'm going to enter selection 2. It pulls down the model locally, so from here on out we won't need to use the API key anymore. So if I just hit enter, it begins running the 16-character model. This is also down considerably, down to 0.15 seconds, down from 17 seconds. So you can generate a significant number of passwords very quickly using this tool. I'll hit Control-C now. I hope you enjoyed this demo. Once again, if you'd like to connect with me, my social media accounts are here. You can also access me on my website. Thank you for tuning in.